Hello, this is topic 1-1 over solving systems of equations by graphing. So let's first talk about what a system of equations is. A system of equations is when you have two or more equations. And here we're more specifically talking about linear systems of equations. The solution to a system is where the graphs of the equations intersect. So wherever we have an intersection, that's where we have a solution. And for linear systems, we can have one, none, or infinitely many. And my spelling is atrocious, so we're going to go with that sideways 8 for infinitely many. Alright. Now let's get to actually solving by graphing. So in order to graph these lines, I first need to solve for y. So I will subtract 2x from both sides. I get that negative y equals a negative 2x plus 8. Multiply everything by negative 1. And I get that y equals 2x minus 8. Now for this one, I subtract x from both sides, and I get that y equals a negative x plus 1. And now I need to graph these two lines. So let me start here. I'm going to start at negative 8. Then I've got my slope of 2, so I rise 2 and run 1. And I get a nice, neat line. Now I graph the next one. I start at 1. I have a slope of negative 1 over 1. So I go ahead and I graph that line. And the point where my two lines cross, right here, that's my answer. That would be at 1, 2, 3, negative 1, 2. And I make sure to write that as a point. So solving by graphing is fairly simple. Solve both equations for y, plot your lines, and you have your graph. Looking at example number 2. Start off by subtracting 2x on both sides. Y equals a negative 2x plus 2. Over here, start off by subtracting x from both sides. Negative y equals a negative x plus 4. Multiply everything by negative 1. And I get that y equals x minus 4 because I flip all of my signs. Go ahead and graph. I start at 2. I have a slope of negative 2 over 1, so I go down 2 over 1. Or I can go the other direction. And I get my line. Over here I start at negative 4. 1, 2, 3, 4. I have a slope of 1 over 1 because there's nothing in front of that x. I go ahead and graph that line. Now I have two graphs. Here's my intersection at 2, negative 2. and that's the answer for number 2. Both of these examples have had a single solution. Let's go ahead and take a look at example number 3. Go ahead and solve for y. I start by subtracting x. Negative 3y equals a negative x plus 6. Divide everything by negative 3, and I get that y equals a positive 1/3 x minus 2. Do the same thing over here. Start by subtracting x. Negative 3y equals a negative x minus 3. Divide everything by negative 3. Y equals a positive 1/3 x plus 1. These are my two equations. Let's go ahead and graph them. We'll start at negative 2. And we rise 1 and run 3. Here, we'll start at 1. And we've got the same slope of 1 over 3. And what you'll notice is that here we have two parallel lines. And so there is no solution. We can also do our null set, which is the 0 with a line through it. So if we have parallel lines, we wind up with no solution. Let's go ahead and see what example number 4 has for us. Subtract 2x from both sides. Negative y equals a negative 2x plus 1. Flip the signs by multiplying by negative 1. And y equals 2x minus 1. Over here, do the same thing. Subtract 6x from both sides. Negative 3y equals a negative 6x plus 3. Divide everything by negative 3. And I get that y equals negative 6 divided by 3. Negative 6 divided by negative 3 is a positive 2x. 3 divided by negative 3 would be minus 1. I plot my lines. I start at negative 1. My slope is 2 over 1, so I rise 2, run 1. I go ahead and graph that line. And when I look at my second line, it's the exact same line. And so what I have is I have the same line graphed right on top of that other one. And so what this gives us is infinitely many solutions. That's the sideways 8 for infinite. Infinitely many. And it's not all real numbers because, hey, I've got a spot right here that's not a solution. But it is infinitely many because there are infinitely many points where these two lines cross because they are the same line. Now, example number 6 is just how we can check our work. So we could have done this on problems 1 and 2, but it's just a way to double check, did I do my math correctly? And so all we're going to do is we're going to plug these numbers in. This is x, and this is y. And so I would do negative 3 times 2 plus 2 times 1, and see what that gives me. That's just 2 into x, 1 into y. Now we'll do the same thing for this one. 2 plus 1. And I would see what that equals. Well, I know 2 plus 1 is 3. Don't need to worry about that. And so that one, of course, checks. But let's check on this other one. I just put it directly in my calculator. And it gives me a negative 4, which is what I wanted right here. And so that checks. And so is it a solution? And the answer to that is a resounding yes. Now, it wasn't a solution until it checked through both equations. If it fails on one, it automatically fails as a solution to the system. Fairly easy assignment. The hardest part of this is probably going to be solving for y. Shouldn't be too difficult. By now you should know how to do that really well. Good luck on your assignment. Have a good day.